Squad. Mr. Herr here on this Tuesday morning. It's at least sunny for now, but they're saying it's going to rain later on. Hopefully, everybody on your end is healthy, wealthy, and wise. Um, yeah, today, ladies and gentlemen, we're going to continue to work with probabilities. Specifically, we're going to start to talk about conditional probabilities. Um, at first, the wording of them is a little confusing, and you might say to yourself, hey, I don't know if I got this right away. But the more you work with them and the more focused you are during the reading, the easier they become. So we'll knock out the notes, and then I have one question, but that's deceiving because it has a whole bunch of parts. One question worksheet for you for HW. Just as a reminder, we took a little poll, and it sounds like we're going to have a Google Meet today at 1 o'clock. So hopefully that suits. Hopefully, we'll see you then. And I don't really know. It's going to be very organic. We'll talk a little bit about expectations, a little bit about what's to come in the course. Mostly just a Q&A and, to see you guys once again. So that's where we're at. All right. Hey, without further ado, let's do this thing. Watch out for the spring. My bad. Hey, you guys know how this goes. Perfect time to grab a piece of paper, pencil, follow along. Just throwing it down there for you. Hey, so conditional probabilities, at least for today, is very much based upon tables. Mathematics is wonderful, but I'm going to be fully honest with you. Once you leave Hempfield, once you leave, any further education, you're not going to use a lot of things like how to graph parallel lines. You're not going to use the quadratic formula. And I'm sorry if I'm suddenly bursting your bubble. But the one thing that you're going to be inundated with throughout the rest of your life is data in tables and charts. So that's really what we're focusing on here. So here we're talking about income distribution. As you can see, it's not exactly fairly distributed, but hey, what are you going to do? So compute the probability that a randomly selected household earns $15,000 to $24,999 in 2006. Okay. The nice thing is this is pretty straightforward. Okay. Looking here at our chart, well, 15,000 to 24,999. That's 12,722. And you want to be careful. It's not people, it's thousands. So in the grand scheme of things, we're talking about 12 million plus people. Okay. But out of what? And this is where the probability, you want to be careful. What we need to do, folks, is we need to add every single column, every piece of data in this column, along with every piece of data in this column. And no, I won't take your, do all that by hand, but add. When it's all said and done, the total here in our chart, which is going to be pretty important here, we end up with 111,618. Okay. So that total, that's what goes in our denominator, because there wasn't a conditional in this case. We'll get to that in question 2. Okay. Now, you might say, Mister, there's no way I'm going to reduce a fraction like that. I fully agree with you. If it was me, which obviously I'm on this end, just make it a decimal or a percent. If you want to make this 0.114, that's fine. Personally, I think percentages, both of which, though, are fine. Even if you leave it as a fraction. Look, I'm not going to get on you because, that wasn't reduced. I get it, man. It's Kuna Matata that way. Okay. Hopefully that's not too bad. Let's look at letter B. Compute the probability that a randomly selected household earned $50,000 to $149,999. Okay. Oh, well, we don't have a category that rolls from 50 to 149,999. So you have to add those numbers up. No surprises there. When you do that, and sorry, I should have had this one ready to go, my bad, you end up with 46,601, still out of your 111,618. If you're saying, Mister, where did you get that number? The 111,618, that's the total in our chart. The 46,601, that is 50,000 all the way up to 149,999. It's those three categories added together. Okay. Then if we write it as a percentage, it's give or take 41.8% of our data values. Once again, if you want to leave it as a fraction, if you want to leave it as a decimal, my brain works in percentages, kuna matata either way. Okay. Hopefully that's not too bad, but it really comes down to the reading. Read carefully. All right. Number two, this applies even more so, and please don't get upset that, it's a pretty serious topic here in number two. I know I'm not trying to be morbid, it's just the way the problem worked out. Use the following data about, helps if you spell right, Mr. Herr, about traffic fatalities in the United States in 2005 to find probabilities below. Okay. Here's the big takeaway when you're dealing with a chart like this. When we start to read, you're going to realize we're dealing with something called a conditional probability. What is the probability that a randomly selected traffic fatality who was between 35 and 54 was male? So we're told something about the person who was between 35 and 54. So we know that they're in this category right here. Okay. Once you start realizing that you're dealing with conditional probabilities, which is what that implies, who was between 35 and 54, what I highly recommend is just pump the brakes and say, you know what I'm going to do? I'm going to find the total for every row, and I'm going to find the total for every column. You might say to yourself, Mr. Herr, what do you mean? Well, and I'll do this very quickly. If you add every row up, so in the under 16 category, there was 208 male fatalities and 149 female fatalities. Well, that's 357. These totals are going to be huge when it comes to our probabilities. So I'm just going to rip through, and feel free to double check my math. I'm just adding across. I'm not including their ages. That's not what we're talking about here. But I am adding the total of fatalities. And yes, I know it's morbid. Don't judge. Okay. Also, you want to find row totals and column totals, especially when we realize our column totals here. You're going to see a huge discrepancy in gender when it comes to traffic fatalities. There's almost 3 times as many male fatalities as female. So gentlemen, clearly we are not the better drivers. Sorry, fellas, what you gonna do? Here we go. So what is the probability that a randomly selected traffic fatality who was between 35 and 54? Hey, we have a total for that. That total is going to go in our denominator, 19,539. Who was between 35 and 54 was male. Okay, well now let's look. Out of that 19,539, 14,680 of those people were male. Once again, you can leave it as a fraction. I'm not yelling if you do, but personally, I think a little more in decimals. Everybody's different, and or percentages. So about 75% of traffic fatalities in that age bracket, 35 to 54, were men. That's not good for me. I'm in that bracket. Watch out, folks. All right, letter B. What is the probability that a randomly selected traffic fatality who was male was between 21 and 34? So I know in this case the conditional statement is that the person was male. So that means my male total, which is why we added the column, is 42,576. I know that, okay? And of those men, how many were between 21 and 34? Ooh, 13,225. Okay. Once again, you want to read very, very carefully, as you probably hear my daughter in the background, because it's easy to get mixed up in the reading. Okay, and that works out to, once again, about 31.1%. Last one for our notes, because I know it's getting a little long. What is the probability that a randomly selected traffic fatality who was female, so that's the conditional, we know the person's female. Well, there's 14,812 ladies was between 21 and 34. Okay, well, let's look here. Of the women, how many were 21 to 34? 4,149. Sorry for the bad 4. Okay. And last but not least, that gives you about 28%. Okay. You want to read carefully. Typically, you'll see the who was. That gives you your conditional. All right. Hopefully, everybody on your end's healthy, wealthy, and wise. Especially given the, morbid thing we're talking about. But I look forward to seeing you guys at 1 o'clock at our Google Meet. I hope that suits. Other than that, have a great day.